Hi, this is Mehul from FloCareer. One of the biggest differentiation of the FloCareer is the way we structure and standardize interviews for our clients. We have a very rich and vibrant forum, a private forum where interview questions are added. Our vast pool of industry experts are the ones who add these questions to that forum. Here, the questions are not just added, but also the proper grading guidelines are also provided. And once we ask this question enough number of times to job seekers, we retire these questions. We obviously don't want these questions to be leaked out on the internet. So today, in today's video, I'm going to walk you through one such interview question which is retired. Now this question is relatively for a junior role, and it is a coding question. So let's just get into it. So let me read the question for you first. The question is, ask candidate to write a program to print all the prime numbers between 1 and 1000, or in a more generalized way between 1 and given n. Once candidate is able to solve the problem, go over multiple iterations to make it more and more efficient. Alright, so let us look at the solution. This is the ideal answer in our forum. Now, I usually like to separate the data and the code. So let me start with the data. Data here is nothing much but a given n number. Between 2 to n, we will find out what are all the prime numbers. And my first solution, a brute force solution, is simply to iterate between 2 to n. And for each number, first we believe that it is not a prime number. Well, it is a prime number. And then we start from 2 and see whether from 2, 3, 4 all the way up to the given number I, if it is divisible. If the first number which is divisible, we break the loop. We don't want to go over it if number is already divisible. As an example, let's say you are dealing with I equal to 9. So you start j from 2 and go up to I, which is 9. So is it divisible by 2? No. Is it divisible by 3? Yes, it is divisible. So that's the time you break the loop. So let's run this program and see how it works. Okay, so I have verified these are all the prime numbers between 2 to 1000. Now, this is a very simple solution, but let us see the statistics. How many people have been able to answer this question correctly? Which I have kept it ready here. In this particular case, only 1% of the people have been able to answer it absolutely correctly. For the 5 stars, you have to do a little extra mile. We'll go through it, what deserves a 5 star. But if you are able to write the program the way I have shown you, then the candidate will get 4 stars. And if they require a little bit of a push to get it done, then 3 stars. 2 stars in when they can write down the program with some help, but it is not 100% correct, right? And 1 star are the one who are not able to write at all. So surprisingly, 38% people are getting 1 star. So now in which situations you will be able to get a 5 star? So in that case, you have to walk the candidate through a path, a journey to make it more efficient. Now, here we don't want to check their math abilities. We are just testing their programming abilities. So our interviewers also help the candidate to explain what is a prime number and things like that. And once they have done the basic programming right, we ask them to force and think through how do you make it more efficient. So one of the things that you can always think about is, okay, if you are testing number, let's say 99, you don't have to check the divisibility all the way up to 98, right? You know that you can probably stop at the midpoint. You don't have to go all the way till 99. So that's one way to make it more efficient. Other possibility, if you start thinking about it, you can make it divisible. If you know that a number is not divisible by 2, you know for sure that it is not divisible by 4, 6, 8 or any other multiple of 2. Similarly, if you know that a number is not divisible by 3, it is not divisible by 6 and 9 or any other multiple of 3. So if you, the question now is, how do you generalize this? You know, and the fact that all the numbers which are not prime has a prime factorials only, right? So let's say 15. 15 is divisible by 5 and 3. So 5 and 3 both are prime numbers. So in other words, the program has to kind of remember all the prime numbers that it has discovered so far and check the divisibility only by those previous prime numbers. Here is a program for that. So you just simply keep a list of primes that you have previously discovered. You have your outer loop from 2 to n. Again, you believe that it's a prime to begin with. And instead of going j from all the way from 2 to given I, you are only going through the given prime numbers, previously discovered prime numbers. And that gives you a much better result, much faster. Let's compare. Let's compare how these two versions how the version 2 is efficient. So for that, I will probably increase these to at least 10,000 numbers so that we can see some visible difference. And we can time it. We can time it both prime v1.py. I don't want the output to be seen here, so I will redirect it. And let's see how much time does it take. And the same story if I just do for version 2. So you can see this is 1.29 seconds, this is 0.2928 seconds. And not in this run, but in the previous run I calculated it's almost 80 to 90% faster when we do this implementation. Now the other thing I just previously talked about was about only checking the numbers till the midpoint. So I have a third variant also, which kind of quits as soon as j from the known primes is greater than half of your given number. But I noticed that is not really helping much into efficiency. So if you see, this is 0.289, this is 0.28273. So the difference is really not that great. So this is how we put a guideline on our forum on how to test the candidate, and only if the candidate is able to give this at least the version 2 of the solution, they deserve 5 stars. The benefit of this whole solution, this approach of standardizing the interview, is that it makes it very fair, and no matter who takes the interview, the grading is consistent. So we will keep publishing a selected retired questions on our YouTube channel. So make sure you subscribe to that, so that you will be always getting more and more information and some interesting questions. Thank you. Okay, here is the bonus material. So how much more efficient the second version of the program is compared to the first version. Now this is not part of the evaluation criteria for the previous question, but for the curious people among you, there is something called prime number theorem. So prime number theorem says that number of prime numbers between 1 to n is approximately n divided by log n. So in the version 1 we had n iterations, and for version 2 we were only dividing the given number by the prime numbers, and the number of prime numbers are not n between 1 to n, obviously it is n divided by log n. So we are making it, if you divide the one by the other, we are making the other the version 1 almost log n times more efficient compared to the previous version. Thank you.